Hello friends, welcome to the video tutorial of C programming. We are studying two-dimensional array, and in this session we are going to see one more example of passing two-dimensional array to function, and the program is for multiplication of two matrices. So let us understand the process of matrix multiplication first, and then after we will see the logic. So assume that I have these matrices. So first matrix is of 2 by 2 order, whereas second matrix is of order 2 by 3. Now here what is the primary condition you have to check? First thing is that your column size of first matrix should match with the row size of second matrix. Means if I consider this as R1 by C1 and this as R2 by C2, okay, then your C1 should equal to R2. If this condition satisfies, then only you can multiply the two matrices, otherwise not. Remember this thing, the column size of first matrix and row size of second matrix should be same. Now what will be the order of resultant matrix? The order of resultant matrix will be R1 by C2. Okay, so this is order of a resultant matrix. So remember this thing. So this is our main primary condition. Now here, since our column 1 and row 2s are same, we can do the multiplication. So let us understand this process. Now let us do multiplication. So how multiplication will be done? So here I'll just mark this row element. So this entire row get multiplied with the second matrix of a column. Okay, let us write it step by step. So 2 into 1 plus 3 into 2. This will give you the element at 0th position. Means this 2 get multiplied with 1, this 3 get multiplied with 2, and then after you have to do the addition of this, so you will get a resultant element. Now the next thing is that you have to multiply this 2 and 3 with a second column element, means this one. Okay, now what you will say, 2 into 3 plus 3 into 5. So again your same row, that is first row, get multiplied with the second column. Now what is the next step? Again you have to multiply the first row element with third column element. So let me mark it. So now we are going to multiply this. Okay, so 2 into 4 plus 3 into 1. So in this way you get the first row of your resultant matrix. Now what is the next step? Now you have to multiply the second row element with each and every column. So let us write it. So 6 into 1 plus 2 into 2. Okay, now currently what we are doing, we are multiplying this row. We are multiplying this row with this first column, 6 into 1 and 2 into 2. Now this second row get multiplied with second column. So it is 6 into 3 plus 2 into 5. Okay, so this and this. Now second row and third column, that is 6 into 4 and 2 into 1. So 6 into 4 plus 2 into 1. Now if you observe the order of resultant matrix, it is 2 by 3. It is 2 by 3. See, we have 3 columns, sorry, we have 2 rows and we have 3 columns. Okay, now let us see function for this. I hope you understand this. Okay, so let us convert it into a logic. So let me switch to the next page. So currently I am not specifying the return type. Okay, so I'll just keep a blank space for it. So let us name our function as multiply. Okay, now here I have to pass three arrays, three two-dimensional arrays. Okay, let us call it as M1, first array as M1, which is input array, the matrices or the one of the matrix that I want to multiply. Second one is M2 array, which is also input array. Here I am declaring both the two-dimensional array of maximum size, and third is my resultant array. So let us call it as M3, and it will be also of size 30. Now the next thing that I have to pass is row and column size of both the matrices. So R1 and C1 are the row and column size of first matrix, whereas R2 and C2 are the row and column size of second matrix. Okay, now let us declare the required local variables. Basically it will represent the row index and column index. Okay, so I and J. So first thing is to check whether column size of first matrix and row size of second matrix is same or not. Now let us write a condition for that. So if C1 is not equal to R2, so I am writing invalid condition first. Okay, so if it is different, then definitely we cannot perform the multiplication. Okay, so here what will I say? Return. Now instead of just saying return, I'll say return 0, means false. I am returning what? False value. And since I am going to return true and false value, which is nothing but 1 and 0, okay, so my return type is going to be what? Integer. So this indicates, this 0 and 1 indicate whether multiplication is done successfully or not. Okay, so if this condition satisfies, your program will terminate here, and if this condition do not satisfy, means C1 and R2 both are what? Same. So we are able to perform, or we are able to do a multiplication. Now multiplication code is little bit complex. Okay, let us understand it. Basically what we are doing, we are multiplying entire row element with entire column elements. Okay, and this will gives you only the element at first position, or element of a single location only. Means in this case it gives you the element at 0th position. So basically we need 3 nested loops. Okay, and there will be a nesting of 3 loops. Okay, so your outer loop will run 0 to R1 times. Okay, so your outer loop will run 0 to R1 times, whereas intermediate loop will run from 0 to C2 times. Okay, now what is this R1 and C2? R1 and C2 is nothing but the order of resultant matrix. Okay, and as we know that outer loop represents what? Row, whereas the inner loop represents what? Column. And the innermost loop is for cross multiplication. Okay, so 2 into 1, then 3 into 2. So that is required for cross multiplication. So it will run either from 0 to C1 or R2. Okay, because the value of C1 and R2 both are what? Same. And that's why we need 3 loops. So outer loop and intermediate loops are to place your element at a proper position, whereas the innermost loop is required for cross multiplication. Now let us write this code, okay, for outer loop, intermediate loop and innermost loop. So let us switch to the next page. So as I told you, my outer loop represents rows, and it will goes from 0 to R1 rows. That means the rows of first matrix, because it represents the row size of resultant matrix. Similarly, the J loop will represent a number of columns in resultant matrix, so it will go till C2, that is the column size of resultant matrix, and J++. And one more loop is required here, okay, for cross multiplication, and for that we need one more index variable. So let me declare it first. So key, okay, you can define some other name also. So let me say for k is equal to 0 and k will go till r1 times, sorry, c1 times or r2 times, okay, because both the values are what? Same, c1 times or r2 times, and k++. Okay, now here how your code works, let us understand it again. See, basically what you are going to do, you are going to multiply this 2 into 1 first, and then you are going to store it in the resultant matrix, okay. Then after you will multiply 3 and 2, and then whatever the previous result is there of 2 into 1, you are going to add the result of 3 into 2. So for that, what we are going to do, we are going to set the ij location of our M3 matrix as 0, because what we are going to do, we are going to add the new content with an existing element. So that's why I am writing this. So M3 of ij plus equal to, what is the meaning of plus equal to? Consider this value first and then after add new value to it, okay, and store the result in the same variable or same array, okay. Now which element we have to consider for first matrix and which element we have to consider for the second matrix. So if you observe here, the data of first matrix is varying by column, okay, your columns are varying, row size is what? Same, whereas in this your column is same, whereas your row value is what? Varying, not row size, extremely sorry. Here your row index is same but column index is changing, and here your column index is same for both the numbers but row index is changing. So what you will say here, M1 of, see, row value will be represented by I index and the changing value, in this case your column index is changing, so I am representing it with k into M2 of, here your row index is changing whereas column index is fixed, so here row index will be represented by changing value, that is k, and the column value by column index by variable j, okay. So this will give you the perfect multiplication. So let us switch to the next page. So here I'll say M1 of ik, because the first matrix data or first matrix column index is varying whereas row index is fixed, and in second matrix column index is varying and we are going to represent it by our innermost variable k and then after j. So remember this thing, how you will remember, see, this particular part, varying part will be represented by k, whereas the I is nothing but your row index and j is representing your column index, okay. Now this part is done, and at the end I'll say return 1 because my multiplication is done successfully. So my function also closes, okay. So I hope you understand this. There are 3 loops. Outer loop represents resultant matrix row, then intermediate loop represents the resultant matrix column size, and innermost for loop will represent the cross multiplication. So that's why they are running up to this limit. So first loop will run up to R1 times, second loop will run up to C2 times, whereas third loop will run up to C1 times. And here what trick we have to remember? You have to remember that the first matrix data or first matrix index is varying column wise, so that's why we represent column index by k, and second matrix index is row index is varying, so we represent row index by k, and I and j are the row and column loop variables. Okay, this is row, this is your column. And why we initialize our ij position of resultant matrix with 0? Because we are adding the current content to it. Okay, if we do not initialize, it will get initialized with garbage value most of the time. See, remember in C we write this kind of statement, sum is equal to sum plus n. So same variable you are using here. So whenever you are writing this kind of statement, in that case it is very much necessary to initialize your variable, otherwise it will have a garbage value. And since we are performing the addition here, that's why I am initializing it with 0, because anything added with 0 is same result. Okay, now let us execute this code in code block. Here I created 3 different functions. First one is accept, that will accept your given matrix, okay, of R by C columns. Similarly, here I write display function that will display the elements of a given matrix of order R by C, and then after I wrote a multiply function. So the purpose of writing accept and display function is that our main code will be less complex and we have to write less duplicate code. Okay. Here to my multiply function I pass three two-dimensional array and the row size of both the matrices or both the two-dimensional array. So here first of all I check for the condition whether my column size of first matrix and row size of second matrix is same or not. If it is not same, then we are saying return 0. But if it is same, then we are proceeding, right? So as I told you, the outer loop will represent the number of rows in resultant matrix. This intermediate loop represents number of columns in the resultant matrix, whereas this innermost loop represents the cross multiplication. So it will run up to C1 times, and then after whatever I explain, okay, according to that we are multiplying. And if these operations are done successfully, we are returning 1. That means we did a multiplication. Now let us have a look to our main function. So if you observe here I declare 3 matrices or 3 two-dimensional arrays A, B and C, whereas row 1, row 2, column and column 2 represents their row size and column size. So flag variable is used to collect the result of your multiplication function, either 1 or 0. So here first matrix row and columns are accepted and the call is given to the accept function. Here the value or the two-dimensional array A is passed. Okay, similarly the second matrix row and columns are accepted and again accept function call is given, and this time B is passed. So just observe the advantage of function. We just wrote that once and we are using it twice. Now call is given to the multiplication function. Okay, 3 matrices are passed or 3 two-dimensional arrays are passed and their row size and column size is also passed. Basically this row size and column size are of our input matrices, and flag value is collected, and if flag is 1 means our multiply function is returning true or false, that is 1 and 0. So if flag value is 1, the if condition evaluates to true, as we know that 1 is considered as true and 0 is considered as false in C. So here I didn't write this statement flag is equal to 1. This is unnecessary, because if flag is 1 it is already going to be considered true, and if it is 0 it will be considered as false. So in that case my multiplication is done, and here I am just showing all the 3 matrices. So first matrix is shown. For that we give call to the display function and its row and column size, and the first one-dimensional array is passed. Similarly second two-dimensional array is also displayed, and then after resultant matrix, that is multiplication matrix, is also displayed. Okay, otherwise we can display the message that can't multiply. Okay, now let us execute this code. So let us enter the order of first matrix as 2 by 2. Okay, now let me enter the element 1, 2, 3 and 4. Let us enter the another matrix of order 2 by 3. Okay, now let me enter the element 1, 2, 3, 1, 2, 3. Now look at here, 1 into 1, then 2 into 1, that is 3. Okay, then 1 into 2, then 2 into 2, that is 6. Okay, so it is showing the correct result, and even the order of resultant matrix is also correct. Okay, it is of order 2 by 3, means the row size of first matrix and column size of second matrix is the order of resultant matrix. I hope you understand this code. Just try to execute with other values, and if you have any doubts, definitely you can write it to me. Thank you.